Well, hello and welcome back to my workbench. It is time once again to try to fix something. And today on the workbench I'll be taking a look at another dead PS5 because that's what I like to work on. This one, the original fat model. I'm not quite sure which model this is. We'll get into it though. This is supposed to be a no power, which is what I like to work on. So let's just see how no power it is. Yeah, we are connected back there. I'm going to give it 120 volts. Nope, I think I saw a power supply start up. You saw that little dip in the volts, in the voltmeter. That means it's a good sign the power supply has started up. So do we have any signs of life? We do not. Okay. All right then. Let's get some covers off. And with the side plate off, I would say this one has definitely been opened up before. Looking at that security tape. Yeah, we're not the first ones in here. Oh well. All right, well I do have the cover off here, and I wanted to see if I had 12 volts, and I do not seem to have 12 volts. I do have AC going in, but just got a little bit of voltage wandering around on that supply, which I think is the 12. I get them mixed up. I think that's the 5, which won't be there right now. But the 12 is not there. Just 1.5 volts kind of wandering around. So we may have a sick power supply yet. Okay. All right, we can deal with that. Well, I have removed the power supply from the chassis and giving it another check with AC going in. Yeah, 1.5 volts just kind of wandering around. That is very strange. That is a very sick power supply. So is that my only problem? Let me grab a known good supply and we'll pop it in that chassis and let's just see if that's the only problem. We'll be very lucky if it is. Well, I dug out a spare 400 FR supply and put it in this chassis. Let's just see if that's all this thing needs. I don't have a monitor hooked to it, but we can see if it gets a white light. Let's give it some AC. Yep, that supply started up. And let's see what she does. Nope. Nope. I didn't see, I even see a light. Oh, it's beeping every time I press the button. Okay. I knew it was too good to be true. I mean, if somebody had been into it, the power supply is dead. And also when I was removing the screws from the back side of this chassis, the two on the back side, the fine thread ones, there were scratches on the head of those screws. So I knew somebody had been in there and changed the power supply. And yeah, it is what it is. So they've combined a dead main board with a dead power supply. Not the first time for that. But yeah, she beeps. No hint of a light. Dead HDMI encoder? I don't know. So we have a power supply to fix over there and a main board here. Let's get to it. All right, well I have removed the main board. Got it out here on the workbench. And I want to see how much current draw we have on this bare board. So let's just see, I'm going to give it 12 volts with a 1/2 amp current limiting on channel 1 there. 13 milliamps. I saw 28 and then back down. Yeah, that's a real quick. That looks like a short, doesn't it? That looks like, oh my, I must shut down in a hurry because something is shorted. Okay. Let me get the overhead camera set up and all that kind of nonsense and see what we can find. All right, I think I've got everything set up. Let's just see where to begin. Where are we going to begin? Looking for a short. I'm thinking HDMI encoder, but I don't know. I don't. The leads are still connected here, but I do not have any voltage into the board right now. All right. HDMI encoder right over here. About here. Okay, that was quick. Yeah. One of the rails on the HDMI encoder, there's like a 0.9 and a 1.8, I believe, that powers this chip. And one of those is shorted. Now, is it the encoder itself, or is it the power supply that generates it? Which, if I can find it on the slim model, they move the, let's see, one of these chips, I'll have to look and see. I can't tell. That may be ground on that chip. This is the 5 volt, this little tiny chip here. And let's see, there's a bigger chip. Yeah, this one right here is a 0.9. And one of these, I want to say, it's not there. It's not there. No. I'm betting on a bad encoder. Okay, let's just pop the encoder off. Why not? And let's just see if that clears our short. I should probably look under the microscope. Because it's very helpful to me. Let's see. Let's see now. I want to look through the microscope, just kind of make sure I don't knock anything off as I remove it. Let's see. Turn my heat up to probably, I don't know, 425, something like that. It does take a little heat to shake this QFN chip off, because it does have a large heatsink pad underneath the middle of it there. I'm just kind of watching for that solder to become liquid. And I think I'm starting to see that. Almost. There we are. She's off. Okay. Now where I was checking for a short was right down here on these two capacitors. Let's do that again right quick, like. Back into continuity mode. Do we still have a short here? No. There. No. It was on this right one that I had the short earlier. So I think we have found our short. Simple enough. I did just recently buy some of these chips. I think these are the Nuvoton replacements, which you'll be seeing on newer PS5s. Exact same chip. Somebody bought the IC product line from Panasonic, so you will see new markings such as that. No problem. Same chip. So I want to try to tin this. I like to tin them. I like to get things in focus too if I could. There we are. Now I should probably put this in a holder because I'll end up chasing it all over the desk here. But sometimes I just hold it down with the tweezers. These chips are rather challenging to solder down sometimes. So I just find it helps to go ahead and tin these side contacts with a little bit of leaded solder. Why not make your life easier if you can? And if you want to know, this is just cheap Kingbo flux. Nothing fancy. And it works for me. There we go. How about a little bit in the middle? Okay. Let's see if we can get it installed. And I think I will probably add some flux and maybe tin those pads a little as well. Although they're not going to be easy to tin because it's got the board to provide a heat sink. But we'll make a good effort at it. Using a bigger iron, of course, because need a little more heat. Okay, I would like these down here to take a little more solder. There we go. And I have burned my flux, which will happen if you use, you have to use a lot of heat on it. So we're just going to clean that off. And start fresh. All right. Let me grab our prepared HDMI encoder IC. Get this fuzz all off of it. And can we turn it the right way? Get it roughly lined up. Like so. And I'm probably going to go with 400C now, because this is leaded solder that I have installed. Don't run away. Come back. Come on now. Make your way back over there. There we are. Okay, now I'm going to get a little downward pressure here. Just a little bit crooked. Just a little. Okay. Close. Probably going to need to do a little touch up around it. Let's see what we can do with this little Pico pencil while the board is still warm. Okay. Okay. Work our way on around. Try to get that back into focus, sorry. long stretch. This side may not need much touching up, but I mean, I did the other side, so. Okay, need to clean that up and see what we have. Let's see. Let me get a little more heat on it. Not much, just want to liquefy this flux. Just to make it easier to remove. All right. I'll be looking. I think we're getting there. We're getting there. Maybe a little more cleaning. Let me clean this up and we'll test it out. Well, our encoder IC has been changed out, and there's our old one sitting over here. Let's give this board 12 volts and see what our current draw looks like now. Up to 300 and come back down. That is exactly what it should look like. All right, I think we're in good shape. Let's get this slipped back into the chassis, and let's just see if she turns on now. It should. Well, and then we got to fix that power supply, but that's another issue. All right, well, I have slipped the chassis back together with my test power supply. We're going to see if this thing will now turn on. That's improvement. Maybe some video. Oh, there we go. It likes to scare you sometimes. That looks good though. I think we're going to come up fully. All we have to do now, come on, there we go. All right, so that looks good. All we have to do now is fix the power supply. So that is next on the agenda. Well then, we are just a power supply away from fully repairing this PS5. So let's try not to waste any time here. First of all, I need to remove the antenna before I damage it. That was easy. Not. All right, so I'm not going to really touch it until we discharge the capacitors, because that is always a good idea. Let's see, because it was trying to output voltage. There's probably some charge on these capacitors. Just a guess. Nothing. Huh. Nothing. Not even a flicker of power. All right then. We'll get to it. See what we find in continuity mode. Oop, that would be frequency. I think the fuse is probably good. Yeah, it is. How about this fusible resistor? It is good. But if that resistor right there is good, then I'm going to say these MOSFETs are good. Because if they had shorted, that resistor would not have lasted long. Do we have a short across these filter caps? We do not. We have a short across the output. We do not. We just have some capacitors charging up. Okay. No burn marks. Let's go right to our DAP 053. So I'm just trying to, just a second to figure out where is pin 1. Okay. Yeah, pin 1 is over here, lower left. So let's get us a ground on that filter cap on one of them. Where is it? There's one. Red probe on that ground. What do we have on pin 1? Open? Oh, I'm sorry, I'm in continuity mode. Try diode mode. 0.7, 0.589 is pin 3. Pin 4, that's ground. 5, 6, 7 is not connected. 8 looks normal. 9 looks normal. 10 looks normal. 11, I think that's a no connect. Not sure though. Nope, it's connected, 0.49. 12 is the no connect. 13. 14. 15. 16. All right, nothing looked out of the ordinary there. Nothing whatsoever. Oh, I'm just now noticing the DNP014 over has a hole in it. Yeah. Yep, didn't see that. I was so focused on the DAP053, I didn't notice the ventilation hole in the DNP014. So, I'll get you a better shot of it here. It is spectacular. All right, let's take a look under the microscope at this newly freshly destroyed DNP014. So that looks an awful lot like lightning damage. I wonder what else it got. Yeah, see, not sure how well it shows up on camera. There's arc marks on the edge of this resistor. Let me get it in the shot. And the edge of that one right there too has arced to somewhere, maybe over to here. It's arced to something. Yeah, look at the edge of that sharp point sticking out right there. That's where it arced to. So it's kind of it's been hot and, you know, melted slightly from the arc right there. So yeah, that would definitely be lightning. So at the least we need a DNP014. There are some other chips like this one here. There's some MOSFETs that could be damaged. And there are some resistors and capacitors that could have changed value in some way. A zener and a regular diode. I guess the thing to do is just take this chip off first. And maybe we can look around and see if any of these zeners or diodes read shorted, you know, while this is off of the board. Alright, with that dead chip off the board, I'd like to look around at some of these diodes that are nearby that may have become damaged. Let's see. That beeped, but it's charging up like there's a capacitor somewhere nearby. How about the other direction? Yeah, there's definitely a capacitor there. I was getting negative readings on the diode check, so I don't know why I thought this would be any different. It's exactly in parallel. So this is hooked to some large capacitors. Let me check this 100 ohm resistor. I think I've had that open up before. 100 ohms exactly. And this is a 20 ohm. That's fine. although it's measuring 16 ohms for some reason. What about these capacitors up here? Just want to see if they're open. 6.8K. I'd have to look up these codes to know exactly what they are. It reads like 7K there, because these have the EIA codes, not the actual values printed on them. All right, what about these opto-isolators? None of them are cracked. It measures about 1 volt. 1 volt. Where this is across basically the base emitter, or the base. This is the input side of it, so I'm trying to say. It's a diode. So it'd be the anode and cathode, actually. Anode, cathode. So it's an LED in there. They all seem to be good. So did it just get the DMP014? What about any short across these outputs? No. No shorts, so maybe the MOSFETs were not damaged. This IC right down here, which is really the only other one on this side of the board. Pin 1, 0.43. Pin 2, I think, is ground. 3.6. That's 0.55. That's ground. I think that's also ground, yes. 0.67. That's capacitor. I'm discharging a capacitor. Okay. That all looks good. Maybe our MOSFETs down here survived. Okay. Well, let's give it a DMP014 and find out what happens next. All right, well, our DMP014 has been changed out. I didn't see anything else, any other obvious damage. There could still be some, but I'd like to apply some voltage to this thing and just see what it does at this point. I am also watching the voltage across the big filter caps right here, which should, in theory, go up to about 395 volts and not really any higher. If it does, then we gotta turn it off in a hurry if it does. So what I'm gonna do is raise the voltage up slowly with this variable isolation transformer here. I'm going to bring it up real slow. You'll see this voltage start coming up on this meter. At some point, you should try to run somewhere about in here, I think. Oop, not good. Not good. What are the? I was watching this back here. Which just went up to about 3 volts of output. Didn't notice what this was reading. Let me bring it back up. That did not sound good at all. That's about right. But yeah, that voltage does not look right. 3 volts. That's with 8 amps of load. Let's turn off the load. Let's see if it'll come up unloaded. No, 3 volts also unloaded. Okay. So let me check though. Power factor corrector is not too far off, so that's probably all right. It'll vary when it's loaded and unloaded. It'll vary somewhat. So we have some more damage somewhere though. Undoubtedly something around that DMP014. That's what I'm thinking. you know, lightning kind of does what it wants. So let me get this capacitor discharged and see if we can find what else is damaged. All right, so our voltage is low. We're running, but our voltage is low, like 3 volts. Let's see. I've been looking around the board, and I think I've found an area that's of concern around this DMP014, which we have changed that out. Didn't seem to affect it, but I mean, it was definitely bad. There was a hole in the other one, of course. But if I can show you, man, we need to get under the microscope for this. We're going to be looking in, here's the DMP014. We're going to be looking just above it in this area right over here, just to the upper left of it. If I can awaken the slumbering microscope. Alrighty, Mr. Microscope. Let's try to keep things in focus. Right in this area. This resistor, not resistor, this capacitor right here. I'm in resistance mode, and if I measure across this, 220 ohms. Okay, keep that in mind, because I have another board here, another working ADP 400 FR. We're going to look in that same area. Right in there, is it? Nope, right up here. Let's try to stay in focus. If I measure across that same capacitor, 1.3 meg ohms. So that's a huge difference. So I think that's where I would like to start, is lifting that. I wake my meter back up. No one told you to go to sleep. I'm going to start by lifting this capacitor and see if that changes. It's a good place to start, I think. Something on my tweezers. I should have cleaned them. Oh well. Let's park it right there. What do we measure across that capacitor now? Are you the culprit? Yes. 237 ohms, 40 ohms out of it. It's broken down. Hasn't completely shorted. If I'm not mistaken, I've had that exact capacitor fail before on another lightning struck PS5. I don't recall the value of it, so the only thing to do is to go back to our good known good board here and lift that one. Where did it go? Right in here. Lift it and see what that is. And see if I can come up with a replacement. I have some, surface mount caps on hand. And some, capacitor resistor kits that I've bought over the years. Put it right there. Cool that down a little so I can hopefully get an accurate measurement on it. I'll use these tweezers. What do we get? 34 nanofarad. It's a very strange value. That is testing at 10 kilohertz. See if I can change the frequency. I think it may have scaled it automatically on its own. These smart tweezers will test it in like 3 or 4 different frequencies. That's at 1 kilohertz. Well, it's also measuring 34.49 nanofarad. So I guess it's actually probably a 33 nanofarad would be a standard value. So I need a 33 nanofarad. Do I have one? I'm unsure of the voltage, but it's not going to be anything terribly high. I mean, this circuit should basically be running at like 12 volts. Unless it takes a lightning strike and then it gets much elevated than that. But 33 nanofarad. Let me see what I can find. Which should be a 0.033 microfarad. Well, I think. Let me see what I can find on hand. Now, hopefully I've got something. I don't think I have a. I think I've already stolen that particular capacitor off the donor I have. I only have that one donor. There's got to be something around here. So the capacitor that we need is designated as C182 on that board. This is my my known good I was comparing to, and I can't seem to find one. It's a 33 nanofarad or 0.033 microfarad, and I'm going to order some 25 volts. This part of the circuit should run at 12 volts, so I think that gives me plenty of headroom. So, but for now, I'm going to remove it from this board. I mean, I've got plenty of them, but I don't really want to destroy this one, but I will replace it. So I'll take it from here, right about in there it is, and we'll put it on our broken board and see if that fixes it. I think it'll probably run without it, but I'd rather be safe and put it in there. So let's get it swapped over, and I will order some to repair this one. Well, I think we're set up to test this board again. I do have my load connected, set on 8 amps over there. I am monitoring the voltage across these filter caps right here, which should hit 395 volts. And I think we are ready to test this, I think. Make sure my load is connected with correct polarity. I believe it is. So we're going to give it straight 120 volts AC and see if she starts up and runs. There we go. Yep. 397 here. Let me check the voltage right here at these terminals, so we get an idea of what we're getting out. If I can do this with one hand. 11911. Okay. I think we're working. That is with an 8 amp load. It looks good. Okay. So that one capacitor had broken down, which I don't think I mentioned it but that capacitor is a an 0603 size. That's what it looks to be. But I need to make a note of that, and I'll get those ordered, because that's at least the second one of those I've seen fail. But okay, I'm going to give this thing a good test, and then we'll put it back in the in its chassis and back into the PS5, and let's just give it a good test there. All right, well, this PS5 is fully reassembled with our repaired supply, and so far it's looking good. It was even a disc in the drive, a Golf 2K23. So yeah, seems to be running the games fine, working fine. I need to remove this sticker from the top of it, it looks like, because it is now working. But yeah, I hope you liked that one. Thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up, and I'll see you in that very next repair. So long for now.